Welcome, everyone. My name is Mo Farhat. I'm a product manager in Google Compute Engine, and this is the Databricks Axion and Action session. So we're going to be talking about Axion, and pleased to be joined here by Gary Chakraborty from Epsilon and Abhishek Rai, Senior Director of Engineering at Databricks, and we'd love to have your attention today. Any questions, we'd love to answer those as well. All right, so let's get started. First, the introduction page. So first, let me start off with some feedback we hear from customers. Customers tell us that AI is becoming an essential part of their businesses today, and then AI is leading to more immersive applications that have higher requirements, performance, and more specialized virtual machine needs. And customers, second, that are well on their way in their modernization journey tell us that they're building now for even more scale, even more efficiency, and looking to use more of the emerging cloud services that are on offer today. And then finally, of course, for traditional enterprises, traditional enterprise workloads, homegrown applications remain bedrock core of many businesses today. We cannot lose sight of the high reliability and stability requirements that those applications need. Right. And let's just spend a little bit of time about how we build our approach here at Google Compute Engine. We analyze workloads across compute, storage, networking, across the hardware and software stack. We work with customers to understand deeply their needs, their problems, the bottlenecks that they're seeing with workloads, and then we design workload-optimized infrastructure to solve these problems. And so just want to spend a couple of minutes here talking about the underlying technology that powers all this innovation at Google. Google has been a pioneer in data center design, has pioneered many data center technologies that power the planet scale services that customers rely on today, search, of course, Maps, YouTube, Gmail, others. And at Google Compute Engine, we make this innovation available for customers so that you too can run like Google. And underlying all of this is the Titanium system of technologies. Titanium is a custom-built networking, security, and tiered offload system that scales performance across bottlenecks in compute, storage, and networking. And on the compute side, we've continued to deliver leading price performance virtual machines, latest processors from Intel, AMD, and of course, now Google Axion. On the storage side, our next generation offering is called Hyperdisk, which helps you scale storage performance independently of the VM up to 500K IOPS, a huge number with Hyperdisk extreme volumes. And on the networking side, of course, we continue to innovate there with the Titanium ML adapter based on CX7 that accelerates machine learning workloads, with our cloud RDMA technologies that are in our latest high-performance computing instances, up to 200 gigabits per second, and ultra-low one-way latencies, less than 3 microseconds, to help scale high-performance computing clusters there. And with that, we now have been investing in expanding the general purpose portfolio and the compute VMs portfolio at Google to meet emerging needs. This expansion continues. We're at a place now where we offer a complete portfolio of machines there to serve every workload, starting with the flexibility of the N and E series VM families, consistent high performance, advanced maintenance controls of the C family of VMs. And this expansion also continues for specialized VMs and now offering, of course, high performance computing options, with the latest being H4D, storage optimized offerings with the Z family of instances, memory optimized with M and X family of instances, and then GPU accelerated machines with the G and A families of instances, including the latest B200 and GB200 offerings that are now available on Google Cloud. And so let's dive in a bit into the C family and C4A and Axion. Right. So first, just a little bit of context here. Why did Google build Axion on ARM, and why should you build on Axion? So Axion today provides the best price performance for the growing ecosystem of ARM-compatible workloads, and provides the best performance per vCPU for key applications there in database, analytics, common serving workloads. And it does this with incredibly efficient performance per watt to help you reduce the carbon footprint of your operations. And so this here is Google Axion. We launched it at Cloud Next last year, and it is Google's first custom server processor. It is the world's fastest ARM-based processor today, with up to 10% better performance than the leading current generation ARM-based instances you can find in the cloud, and up to 65% better price performance, up to 60% better energy efficiency than the current generation x86-based instances on Google Cloud today. And just key here that we built this machine on standard ARM compute cores. And we did this to give you access, low friction access to the expanding ARM compatible software ecosystem, but also to make it incredibly easy for you to migrate your workloads from existing ARM-based instances in the cloud to Axion and run ARM multi-cloud as well. And to do so with minimal to no effort. Right. So to just dig a little bit deeper into the VMs themselves here. So the Axion's available, powers the C4A virtual machine family. C4A virtual machines provide a complete range of general purpose sizes, the 72 vCPUs, 2, 4, 8 gigabytes of memory per vCPU, 6 terabytes of local SSD storage, again, based on titanium SSDs that provide 35% lower latencies, particularly beneficial for database workloads and analytics workloads, and up to 100 gigabits per second in tier 1 networking. Of course, all built on titanium and full support for hyperdisk, balanced and extreme today. Throughput's coming very soon. All right, so I'll end with this. Please try C4A. Try C4A on Axion. I think you'll be very impressed. And please welcome Gary Chakraborty. Welcome, Gary.
Thank you, Mo. Hello, everyone. My name is Gary Chakraborty. I'm a VP at Epsilon. Epsilon is part of Publicis Group, who is world's largest marketing providers at this point of time. What Epsilon does is people ask Epsilon a simple question in terms of marketing. How can I improve ROI, return on investment of marketing dollars? To do that, Epsilon performs certain operations. One is identify the real person whom do they need to reach. Second thing is at what time they should reach and what message they should give. And third is what are the messages, what are the consistent messages they need to provide customers so that you can convert them as that particular brand's customer. So that's the overall marketing spend, and how we do that, I'll just go through in a glance. So on the left-hand side, you will see different kind of a data source. When we do the marketing, we actually market to real customers. And that's where Epsilon's power of identity comes into picture, where we can identify a real person to send the right message at the right time so that brand can acquire themselves. In the middle, you see different services of Epsilon, like CDP, which is a customer data platform. It has all the customer details information. We have Clean Room, where along with Databricks, we can find out, we can activate the customers, we can build an audience in a privacy safe manner. Everything Epsilon does is in a privacy safe manner. And every brand, we can connect their first party data to Epsilon's own data set to provide a much larger reach. Then we use our messaging solutions to send the message. It can be either email message, personalized email, text, or display messages in your connected TV or anywhere using multi-channel messaging capability. And then we can use activation through own channel or paid channel. It can be Epsilon Digital, or it can be even YouTube, social media, any other channels. And at the end, on the right side and in the below, we are showing the entire Databricks Lakehouse platform, which powers these solutions. We use Databricks Delta Lake. We make sure all of the objects are optimized using liquid clustering, predictive optimizations enabled, and Databricks Lakehouse provides a complete entire picture using auditing, data lineage, everything in one get-go. Now, when we talk about all these things, like ARM-based architecture plays a significant role in Epsilon's data processing. And we process the data in multiple clouds, in all three hyperscalers, basically. And that's where I will talk about the use case, how ARM-based architecture helps to solve these solutions. In this particular use case, where we use Axion, it's kind of a data warehouse use case. The POC was over a 65 terabyte of data set. It has a significant amount of joins and large aggregates built in. The result there, it has large amount of shuffle, both shuffle reads and shuffle write operations. We will go through why it is important and how basically this new Axion systems are helping us. And this has been run by several data scientists for ML jobs, because we are using one lakehouse architecture where the data lake, where all the ML job runs, and data warehouse, where all the BI analytics job runs. It runs on a same data source so that we have one system of truth. And all these use cases, we are comparing with both x86-64 architecture along with newly released ARM64 architecture machines in GCP. From a runtime perspective, Databricks, we use 15.4 runtime in this use case, but eventually we will also use 16.4 DBR MLR as applicable. And AQE, which is part of the, again, Databricks features, which helps significantly, basically, wherever we have a data skew, AQE helps a lot in this kind of a scenario. As I mentioned, all tables are already using liquid clustering. So here is the result. Couple of things I wanted to highlight here. Number one, we used x86-64 in GCP versus ARM64. Two things I wanted to segregate very specifically here is, one, we used ARM without local SSD, and the second one, we use ARM with local SSD. There is a significant difference in performance with or without local SSD. I'll explain it why. The data set which Epsilon executes in most of our marketing applications, we are talking about multi-petabyte data set. And over here, there is a significant amount of shuffle happens. There are spill happens, auto scaling of the disk devices happens. When we use local SSD on that, the overall performance and throughput, what you will get is substantially higher, and your runtime drastically reduces. This is one of the area. That's why you will see the first use cases with local SSD and the second use case without local SSD. There is a significant difference. But the important thing to note here is, in the x86-64 architecture, when we used even with local SSD, ARM architecture with a C4 instances, it's giving us still more than 20% performance improvement and anywhere between 10 to 15% cost advantage. So that's the key, and we have seen this C4A instances are providing possibly the best result across all of the cloud platform that we have run. So this is overall observations of our use cases. Is like we tested it 2 months back when it was released and Databricks started supporting it. And overall performance in terms of the throughput and in terms of what we need is really helping when we are using C4A architecture. Now, one thing to note as well is, depending on the application you run, it needs to also be compatible with ARM. Not every application is compatible with ARM. So that's one use case which Abhishek may touch up later on. So this is the overall impact. Because of the using local SSD on top of ARM, we are getting significant speed up in terms of shuffle, read, and write, and that gives a massive boost in our application throughput. This is the final story, Epsilon's unified lakehouse solution, what we are deploying in multiple cloud and also in GCP, where this entire C4A instance plays a key role over here. You will see in the center is Epsilon's common data set, which includes identity, which includes all of the various attribute informations, which we connect with customers' first-party data in a privacy-safe manner in customers' own area. Think of it in a GCS storage for customer, and all of the compute is also dedicated for that customer. So there is no data sharing or anything cross-customer. And this powers basically all of the application, being it clean room, being it CDP, loyalty, or any activation platform, retail media network, messaging. You can think of it's a collection of lakehouse, connected lakehouse, which can talk together to provide all of the features that a customer needs to make sure the campaign is successful. They can start the campaign, they can build audience, they can activate audience, they can measure real time and figure out if the campaign is performing well or not. If not, they can change it dynamically without waiting for the entire campaign to end and giving them not the satisfactory result. So they have all these things, and all of these options are flexible for customer to choose at any point of time in any cloud of their choice. And this is what we are deploying at GCP. Now I will hand over to Abhishek. He will take us to the rest of the parts using Databricks Platform.
Cool. Thanks, Garrick. Hey, everyone. This is Abhishek Rai from Databricks. I'll be continuing the story on Axion and share our perspective on what we are seeing with Axion across our customers. First, a quick recap of Databricks itself. As you might be aware, Databricks primarily serves 3 use cases across our user community: data analytics for data analysts, data engineers, data scientists, and AI/ML engineers; Databricks SQL Warehouse, which is more than $500 million business today. It's our fastest growing product; and Gen AI, where we are rapidly growing our user base. It is our point of view that Gen AI will not succeed without governance, and that's where Unity Catalog comes in. Probably heard plenty about that in Dias this time. Also, quick recap of Photon, which is essential to our Axion story. So Photon is the fastest native performance engine built from the ground up for modern cloud hardware. It provides up to 80% better performance and up to 12x better TCO. Most importantly, Photon is 100% compatible with Apache Spark. So in order to benefit from Photon, no code changes are required. And finally, Photon is built to support all use cases, all data use cases. So it is really a drop-in replacement for Spark. With that context, let's move on to key factors for us to select Axion. First of all, Axion offers pretty significant performance improvements right out of the box, up to 40% better compared to second-gen instances. The ARM-based Axion cores, they are designed from the ground up to provide maximum benefit for data-intensive workloads, similar to what Databricks runs. We are also very excited about the improvements in the storage stack that come with the Axion platform. Specifically, hyperdisk storage allows you to independently scale performance and size, which is a great win for TCO and performance. And we also have observed that, as I'll cover in the next slide, the combination of titanium local SSDs as well as hyperdisk storage, like what Garrick mentioned, that is really very helpful for data-intensive workloads like Databricks. ultimately helping with both performance and TCO. We're also very excited about the networking stack in Axion because it's able to support encryption at full line rate, something that's very important for us from enterprise security point of view. And on that note, Axion overall fits in very nicely with our data security architecture. With that, let's go over the results of our experience running on Axion and helping our customers adopt Axion over past several months. First of all, Axion really lives up to its promise. We are seeing performance gains up to about 50% compared to second-gen instances and about 40% compared to third-gen instances. These performance gains, most importantly, come without any code changes or deeper optimizations that anyone has to make. Another important call out is that in addition to the performance gains, there are very consistent TCO gains as well that we are seeing across the board. And that also is a pattern we are seeing across a whole range of workloads. So a whole range of workloads from compute intensive, data intensive, everything gains with the Axion platform in a very consistent fashion, including IO-bound workloads. So the examples that Garrick mentioned earlier, where you see a difference between local SSD and hyperdisk performance, the huge jump there, a lot of that signals like IO-bound workloads. With hyperdisk storage, we are seeing that hyperdisk and titanium local SSD combination, we are seeing pretty consistent improvements. Databricks has a capability called disk auto-scaling, where we are able to dynamically grow your remote block storage to match your storage and IOPS needs. And that is very handy in ensuring that you're not overpaying for IOPS. You're mainly paying proportional to the amount of compute you are using. In fact, one of the nice things with the hyperdisk stack is that we've found the flexibility so powerful that we are actually backporting that support to third-gen instances where we previously did not support hyperdisk storage. Also, one important call out is that it's ultimately the hardware and software combination that you have to take together to maximize your wins. As the chart on the screen shows, the maximum gains come with Axion on Databricks when using the Databricks Photon engine, the native execution engine I mentioned earlier. As a concrete example from this, you can see that when we move from Databricks Photon engine on N2 to Photon engine on C4A, we get about 50% performance improvement. Going from Spark on N2 to Photon on C4A is a 10x performance improvement. And in hindsight, that's not really a surprise because we really love the Axion platform, the titanium platform architecture that Mo described earlier. And Databricks Photon engine also is really optimized for native execution on such a modern platform. One important call out is that when used with Databricks, the Java version does matter. Java received many important ARM-related upgrades between earlier versions and JDK 17 and onward. So that's something you want to take along. Just another quick deep dive on some of the benchmarks. So this slide shows our end-to-end benchmarks as well as some micro benchmarks. Specifically, it compares Axion or C4A performance compared to third generation x86. You can see pretty broad improvement across the board. Most importantly, like I mentioned earlier, no code changes, no optimizations. It's exactly the same code running on both platforms. In fact, it was this result that really simplified our choices with respect to A, recommending Axion to our customers, and B, ourselves adopting Axion in Databricks' own serverless offering. So we are going full throttle with Axion in our serverless offering on GCP. Databricks serverless, just to recap, is a platform that's designed to provide much better customer experience and TCO through cutting-edge intelligence built into the platform and several other optimizations that we've built in every single product of Databricks integrating into serverless. So that is going full Axion. Finally, I'll leave you with a few tips. First of all, Axion is a great platform. As the capacity is coming up, built for both x86 and ARM, and I think that might be true even in the long run. That will just give you maximum optionality. For Databricks customers, adopt Fleet. Fleet is our flexible offering for falling back to whatever instance types are available. I'll cover that in the next slide in a little more detail. Don't ignore the software, like I mentioned earlier. So Java was one example where use a newer JDK version that'll help you tremendously. And for Databricks customers, that would mean using a newer version of Databricks runtime with Photon engine. Finally, embrace hyperdisk. It is really transformative. The ability to separately tune performance and size is super helpful. With that, just a quick note on the Fleet offering I mentioned earlier. So Databricks Fleet is in private preview on GCP. It provides two broad capabilities. Number one, it frees customers from having to worry about capacity issues or configuring fallbacks at your own job configuration level when the preferred SKU is not available. Now you can push your capacity requirements into Databricks in terms of the fallback SKU order, for example. In addition, Databricks can automatically pick the right instance queue for you. And that's something that our users use very heavily, the users who've onboarded and the users who've used it before on AWS, where we've had the Fleet offering before. Another very important win of the Fleet offering, which you'd strongly recommend using that as well, is it significantly improves Spot usage on Databricks. So normally on Databricks, when you're using Spot, in most cases, you have Spot with fallback to on-demand that's configured. But with Fleet, you can effectively have a dozen different options of Spot tried before you give up on Spot eventually, for example. So that way, adopting Fleet will give you the maximum optionality, being able to leverage ARM, and when not available, you can fall back. And also it'll help you maximize Spot availability across whole range of SKUs. That's all I had. Thank you.